When it comes to solving quadratic equations, one look can tell us the whole story. If it's an equation with no x term, just x squared and a number, we use method number 1 and solve it finally by taking the square root. We've seen that in another module, and we'll see it again in a moment. If the equation does have an x term and can be factored, we use method number 2 and solve it by factoring. In the module on factoring, we saw that as soon as we have two factors equal to 0, we have the key to the whole equation. Now we're going to handle a quadratic equation which looks like nothing but trouble. Will method 1 work? No, the equation has an x term, 6x. Will method number 2 work? No, the equation isn't factorable, so we have to resort to magic. Two kinds. First, we'll find and use a magic number. Second, we'll do a quick shift right back to method number 1 and finish up almost instantly. So let's make sure we remember method number 1 in its simplest form. That's the one where the equation has no x term, just an x squared term and a number. First, I get rid of that 3 in 3x squared by dividing everything on both sides by 3. And then I get the x squared all alone by moving the 6 to the other side. Then I can either use common sense and say, if x squared equals 6, then x has to be the square root of 6. Or, same thing, I can take the square root of both sides of the equation, which gives me the answer. X equals the positive or negative square root of 6. But notice now, and this is important, that if you had something else squared there on the left, even a whole expression squared, you could unsquare it in exactly the same way, by taking the square root of both sides. Remember that. We're going to need it, but not quite yet. Right now, we're still stuck with that equation that won't work, because it does have an x term, and it doesn't have any factors. A question. What would happen if we could change the uncooperative expression on the top here into the very cooperative one on the bottom? The answer? We'd quickly find that x squared plus 6x plus 9 is a perfect square, x plus 3 squared. So we could shift right back to method number 1, take the square root of both sides, and get our final answer. X equals negative 3 plus or minus the square root of 10. Okay, it would work if it had that form. But it doesn't. Question, how can we give it that form? How do we get from our original equation to the one that turns out to be a perfect square? Simple. We use the magic number. We add exactly the right number to both sides, and it works. In this case, the magic number is 9. Great, but how did we find the magic number? What's the process? The quick answer is take the coefficient of the x term, divide it by 2, and square the result. The slow answer is take the coefficient of the x term, the 6 in 6x, divide it by 2, 6 divided by 2 gives us 3, and square the result. 3 times 3 is 9. so we add 9 to both sides of the equation. By doing that, we turn the expression on the left into a perfect square. That's why this method is called completing the square. If you don't quite see yet why this method works, try looking at it this way. You find the magic number, the third term, by taking everything in the second term except x, dividing it by 2, and squaring whatever you get. But you can do the same thing to any other perfect square, and the answer will always be the third term. Take x plus anything, square it, and look at the expression it gives you. Here, x plus a squared gives us x squared plus 2ax plus a squared. Now, if we had only the first and second terms, could we find the third one, the a squared? Sure we could. How? By taking everything in the second term except x, dividing it by 2, and squaring whatever we get. Everything except x in 2ax is 2a. 2a divided by 2 is a. Squaring a gives us a squared, and a squared is our third term. A perfect square will always take this form. That's just the way they are. So once again, here's the recipe for the magic number, the third term in a perfect square. Use that recipe now to find the magic number for this one. The second term is the key, 8x. Coefficient, 8. Divide 8 by 2, we get 4. Square 4, we get 16. 16 is the magic number which we add to both sides. Now the expression on the left is a perfect square, and we write it that way, which gets us right back to method number 1, the square root method. Why? Because taking square roots works whenever we have just a square and a number. Exactly what we have right now. So we take the square root of both sides, get the x all alone on the left, and we have our answer, or rather our two correct answers as usual. X equals -4 plus or minus the square root of 21. And finally, you're ready to do a problem of your own from start to finish. By finding the magic number, adding it to both sides, and using the square root method to get two correct answers. When you have them, come back. Turn the tape off. First, I want to find the magic number. I take the coefficient of the x term, 10, divide it by 2 to get 5, and square that to get the magic number, 25. And then I add it to both sides, factor my perfect square, and use the square root method to get my two correct answers. Our problems so far have been easy because they've all had a special shape. The coefficient of x squared has always been 1, and the number term has been on the right. That tells us something. Keep that shape, and we'll keep them easy. So what if we're handed something like this? The coefficient is not 1. The number term is not on the right. What can we do about that? Plenty. By dividing both sides by 2, and then adding 7 over 2 to both sides, and then guess what? It has exactly the nice, easy shape we're looking for. In other words, be sure to be lazy. Don't work any harder than you have to. Try this one now. Just reshape it into the easy form. Don't bother solving it now. Come back as soon as you have a plain x squared and the number term on the right. I have to get rid of the 3 in 3x squared, so I divide everything by 3. Then I need that number over on the right, so I move it. And that's it. Congratulations, you have now seen every one of the steps used to solve a quadratic equation by method number 3, completing the square. Take a look now carefully at all 7 steps. Now we're going to use those steps, all of them, in solving a problem. This problem, 3x squared minus 9x minus 12 equals 0. Step 1, change the x squared term so that it has a coefficient of 1. How do we change 3x squared to x squared? Divide all the terms by 3, and we've got it. Then we get the number term, 4, over on the right where it belongs. What's next? The magic number. Coefficient, 3. Divide it by 2 to get negative 3 over 2. Notice now this middle stage in your calculation because we're going to see it again in just a minute. Then square the negative 3 over 2 to get the magic number. This time, surprise, it's a fraction, 9 over 4. We add the magic number to both sides. This step is crucial because it gives us a perfect square on the left, which we can factor and rewrite as a square. And here it is. How did we know that the second term would be negative 3 over 2? Because we saw it just a moment ago in the middle stage of calculating our magic number. It always works that way. Now the square root method, method number 1, takes over. We take the square root of both sides and then get x alone on the left. And simplify to get our two right answers. Completing the square is a long process. Often another method works better in solving a quadratic equation. But you'll need this technique later when you handle areas like these. For more information on this process, check these pages in your text. And do some of the sample problems you'll find there too. You need the practice, and the time is now. Use this problem as a warm-up first, and then you'll be ready to go it alone. I follow the whole list of steps, like this. 1. Make the coefficient of x squared a 1 by dividing. 2. Get the number term on the right. 3. Find the magic number. 4. Add the magic number to both sides, and right away, step 5. Factor on the left and simplify on the right. Step 6. Take square roots on both sides. And finally, step 7, get x alone on the left and simplify on the right as far as you can. And that's it. A few more like that and you'll be ready for one last method of solving quadratic equations. Good luck, and we'll see that one in another module.